This is Geometry Unit 10, Day 4. These are the notes for the volume of a sphere and the composite solids. A sphere is a set of all points in space equal distance from a given point. And that's the center of the sphere. So notice that this definition doesn't say in a plane. A plane would be on one surface, which would essentially be a circle. A sphere is three-dimensional, so it's on that one surface and it's every direction other than that. It's all equal distances in all directions. The formula for a sphere is 4/3 pi. It's pi because it's like a circle. It's r cubed because it's volume. 4/3 is the ratio of that, where r is the radius. So we're going to look for the exact volume of this sphere. The sphere has a radius of 12. So to find the volume, how much would fill up the inside? 4/3 pi r cubed. Twelve cubed is 1,728, and your exact answer, remember, is going to have the pi with it. So we're going to divide this by 3 and multiply it by 4. You can use your calculator, and that would be feet cubed. Notice an exact answer is going to have the pi symbol involved. We're not going to get a decimal and round it. A beach ball has a diameter of 15 inches. So if the diameter is 15, then the radius is 7.5. So now we can calculate the volume. Using our formula. The more times you write the formula, the more confident you're going to be remembering it. (7.5) times 7.5 times 7.5 . So when you multiply by 4 and divide by 3, that would be our exact answer. And then with a decimal version, this would be inches cubed. Find the radius of a sphere if the volume is 36 pi. Well, again, using our formula, we have 36, and notice the pi symbol is part of the volume. It's very helpful in terms of keeping nice clean results, clean answers, if pi is part of the answer, because when we divide by the pi, they can cross off and we don't have to deal with any decimals. Now, how we deal with this 4/3. The first thing we're going to do is multiply both sides by 3. So if you multiply this side by 3 and this side by 3, you'd get 12 divided by 3, which is 4. Or you just cross the 3's off and you're left with the 4. We have 108. Equals 4r cubed. Then we're going to divide by the 4. 4 is going to go into that 27 times. what would we need to do now? It's not called the square root, it's called the cubed root. So we're looking for what times what times what makes 27. And it's 3 times 3 times 3 that makes 27. So 3 equals R. So that is 3 centimeters. It's a length, so it's not cubed or squared. Now a composite is of two or more solids put together. And here we have the volume addition postulate. The volume of a solid is the sum of the volumes of its non-overlapping parts. So when we look at something like this, we have two different parts that we need to calculate. We have a pyramid plus we have a cube. We have those two pieces together. So a pyramid, remember the formula, and the cube's formula is length times width times height, or BH would be fine also. So the base of the pyramid is the same as the base of the cube, so 6 by 6. The height happens to be 6 also. The length times width times height are all 6's. So when we say 6 times 6 times 6, we're getting 216. When we take 1/3 of 216, we get 72. So that gives us a total of 288. And these are meters cubed. For this composite solid, we're looking for half a cylinder plus we have a cube on bottom. So we're going to take half the cylinder, which is pi r squared times the height, and the cube, which is length times width times height, or base times height. Maybe you want to call it BH. Either way you want to think about it. So we have half pi. Now what is the radius of our cylinder? 4 goes across the whole shape. So 2 would go across just half the shape. And the height, remember the height is the distance between the circles. So what's the distance between our two circles, or half circles for this case? The area of the base is 4 times 4, and the height is also 4. Four times 4 is 16, times 4 is 64. That would be our exact answer. We couldn't break that down much more than that. And then we're going to add the two together. These are inches cubed. On the next side, we have a pill capsule. We have a cylinder, and we have two called hemispheres. So we have a cylinder, and the two halves make up a whole sphere. So we know for the cylinder, we say pi r squared times the height. And for the sphere, we have our new formula of 4/3 pi r cubed. So we have a cylinder and a sphere. So we see that the radius is 2. The height, remember, is the distance between the circles, so that's 7. The radius of the sphere is also 2. So 4 times 7 is 28. So we have our 28 pi plus we have 32. That's 4 times 8 divided by 3 pi. So using our calculator, when we add those two together, we get 121.47. These are centimeters cubed. A solid consists of a hemisphere, that's half of a circle, or half of a sphere. It's a circle, that's the big bubble, with a radius of 1 on top of a cone, with the same radius. So there's our cone, and then we're going up on top of it with the radius. The radius is 1, and the height of the cone is 5. So we have a cone plus we have half a sphere. So the cone formula is pi r squared, 1/3 pi r squared times h. And the sphere is 4/3 pi r cubed. Notice I write out the formulas each time. 1/3, 1 squared times 5, and 1 to the 3rd power. So 1 squared is 1. So now we're going to have 5/3 pi, because it's 1 times 5 divided by 3. 1 times 1 times 1 is 1. So now we're going to have 4/6 pi. So that's going to come out to be, using our calculator, 7.33 meters cubed. Here we have a pool. Here are the dimensions. So it starts out 4 feet deep, and it slinks all the way down to 10 feet deep. We're looking for the volume of this. One way to think about it is that if you have 4 feet here, and if you extend this false bottom all the way across, you would still have 4 feet. Then you would have this triangular prism on this side. So we have a rectangular prism, which is on top, and we have a triangular prism on bottom. So the rectangular prism to calculate the volume, it's base times height. And here we have base of the triangle, which our triangle is half of base times height times height. So it's kind of like height 1 and height 2. Height 1 is of the triangle, height 2 is of the triangular prism. So our base here is going to be 164 times, let's see, 164 times 82. Times 4. Our triangle here is going to have 6 feet left over, because if it's 10 from the top to the bottom and part of it's already 4, then the remaining part is 6. $164 So we do half our base times height times the distance between the two triangles, which is 82. So you need to look at what we're trying to calculate. We have this rectangular prism on top, which has a length of 164 and a width of 82. And it has a height of 4. So that's the volume. And we'll use our calculator. It'll be 164 times 82 times 4. Then we have our triangular prism. This triangle has a height of 6 by 164. We take half of that because it's a triangle. Half of 6 times 164. We can times that by 82. And we get 94,136 feet cubed. If we're looking about how many gallons that would be, then we're going to divide that number by the number of gallons, or by what it takes to make a gallon, actually. So we have our 94136 divided by 7.4805. So we're looking at 12,584 gallons. if you can fill the pool with 23 gallons per minute, then we're going to take our 12,584 and we're going to divide that by 23. How many groups, how many minutes? If 23 of those can happen in a minute, we have our 12,584 divided by 23. So it's going to take 574.14 minutes to fill. If we divide that by 60, that tells us how many hours. 9.12 hours to fill. Because there are 60 minutes in an hour, we're breaking the minutes into groups of 60 to figure out how many hours there are.